We should start with the definition of statistics. Statistics is the science of collecting, describing, and interpreting data. We'll talk about what it means to collect, describe, and interpret data. First, we have to talk about the meaning of the word data. Data is just a collection of information that's been recorded. And the word data is actually plural for the word data value. A data value is a single piece of information that describes something about a person, animal, thing, or place. When a person completes a survey, each answer that the person provides is a data value that describes that person. For example, if I ask a person, how tall are you? And the person says 61 inches, then 61 inches is a data value that describes that person. Even though a data value can be a number, it doesn't have to be a number. It can also be a word. If I ask a person, what's your major in college? And the person says psychology, then the word psychology is a data value that describes that person. Let's look at some examples of data values. If a person is 61 inches tall, then 61 inches is a data value that describes that person. It's a data value because it's a piece of information that tells us something about the person. If a dog weighs 45 pounds, then 45 pounds is a data value that describes that dog. In this case, 45 pounds is a data value that tells us something about the dog. If a house is 200,000 square feet, then 200,000 square feet is a data value that describes the house. 200,000 square feet is a piece of information that tells us something about the house. If a book is a hardcover, then the word hardcover is a data value that describes the book. This is an example of how a data value doesn't have to be a number. The word hardcover is a data value because it's a piece of information that tells us something about the book. The word data is used whenever a person is talking about more than one data value. If I have recorded the height of one person, then I have recorded one data value. If I have recorded the heights of 10 people, then I have recorded data. The word data is plural for the word data value, so data is just a collection of data values. Put together, these four data values would be called data. So you could say that there's data inside of the circle. These four values are called data because there's more than one of them. Once a collection of data has been completed, it's called a data set. The final goal of my study was to record the height of a person, the weight of a dog, the price of a house, and the cover of a book. Then these four data values would be my data set. Let's now talk about what it means to collect, describe, and interpret data. Collecting data means seeking out and recording data. It just means gathering and recording information about people, animals, things, or places. People collect data for a variety of reasons. One reason is to learn about the world. The goal of any science, including psychology, is to learn about the world, and we have to collect data if we want to learn about the world. Another reason is to make predictions about the future. Here are a few examples of situations in which people use data to make predictions. A restaurant manager will need to predict how many customers will arrive on a certain day so that they know how many employees to schedule for that day. In order to make that prediction, the restaurant owner needs to know how many people usually visit the restaurant on that day of the week or on that day of the year. Also, people who work in college admissions need to be able to make predictions about which applicants are the most likely to perform well in college. In order to make those predictions, they need to gather data such as SAT scores and high school GPAs. Meteorologists also have to collect data so that they can make predictions about the weather. A third reason why people collect data is so that they can make decisions. If a business owner has collected data on his or her sales, and the sales numbers are low, then that business owner might decide to spend more money on advertising. Describing data means communicating your data to others. The person who collects a set of data is usually trying to answer some type of question. After the data has been collected, the person will want to share the findings with other people. If you want to clearly communicate your findings to other people, you have to summarize your data set, such as by creating a table or a graph. You can't just show people your list of data values. If you do, then the person would probably have a difficult time making sense out of it. It would just look like a list of random numbers to the other person, and the person probably wouldn't be able to understand what the data is showing. So it's important to summarize a set of data so that other people can understand what your main findings are. There are different ways to summarize a set of data. One way is by calculating a set of values that summarize your data set. These values can be called summary values, but later in the class we'll talk about how the technical word for them is descriptive statistics. Descriptive statistics are values that are calculated to summarize a set of data. Two of the most common values that are calculated to summarize data are means and percentages. Another way to summarize a set of data is by creating tables, charts, and graphs. Now we've covered collecting data and describing data. Now we'll talk about interpreting data. Interpreting data means reaching a conclusion about what your data is showing to be true. If a teacher has recorded the exam scores of his or her class and then comes to the conclusion that the students did not perform very well, then the teacher has interpreted his or her data set. In social science, we want to be able to reach conclusions about people. Usually the conclusions that we reach in social science aren't guaranteed to be correct. That's why a social scientist who has collected a set of data can say that something appears to be true, but can't say that something has been proven to be true. I want to talk a little bit more about why this is the case. Researchers in social science are interested in studying large populations of people, such as men, women, or college students. A social scientist who is studying a large population of people won't have time to collect data from all members of the population. Instead of collecting data from all members of a population, a social scientist will almost always select a small group of population members and collect data from those people only. For example, a researcher who wants to learn about the U.S. college student population might collect data from 100 college students who live in the U.S. When a small group of people who are members of a population provide their data to a researcher, that small group of people is called a sample of the population. We'll talk more about the samples later on in the class. A sample is a group of people that the researcher selects from a population in order to gather data to learn about the population. It actually isn't possible to use data from a sample to prove something about a population. The only way to prove something about a population and to be 100% sure that your conclusion is correct is by collecting data from all members of the population. When you collect data from a sample, it's always possible that the sample that you selected is an unusual group of people who is providing you with misleading information about the entire population. A person who has collected data from a sample can conclude that something appears to be true about the population, but the person has to admit that he or she might be wrong. Whenever a person collects data from a sample, the person has to realize that every member of the population that he or she is studying is a little bit different, and the conclusion that he or she will reach about the population will depend on the specific people who end up in the sample. Now I wanted to give an example of collecting, describing, and interpreting data. Let's imagine that I'm a researcher who's interested in whether working college students are getting enough sleep. I'm interested in whether working college students are sleep deprived. I asked 10 working students and 10 non-working students how many hours of sleep they are getting each night, and I record their answers. These are the answers from the 10 working students, and these are the 10 answers from the non-working students. For example, this working student said that he or she sleeps 7 hours per night. This working student said that he or she sleeps 6 hours per night. This non-working student said that he or she sleeps 7 hours per night. By recording these 20 answers, I've collected a set of data, and by looking at the 10 numbers over here and the 10 numbers over here, you can kind of get an idea that the 10 non-working students are getting more sleep than the 10 working students. But it would stand out much better if we summarize the set of data. We could summarize this set of data by calculating the mean, or the average, of the 10 working students, and by calculating the mean or average of the 10 non-working students. If I wanted to calculate the mean of the 10 working students, I would add their 10 answers and divide the total by 10. And if I wanted to calculate the mean of the 10 non-working students, I would add their 10 answers and divide the total by 10. And then my two answers would be the mean of the 10 working students and the mean of the 10 non-working students. Once I've calculated those two means, I can create a bar graph showing the mean of the working students and the mean of the non-working students. The bar graph would look like this. If you tried adding these 10 numbers and dividing the total by 10, the answer would come out to 6.9. If you tried adding these 10 numbers and dividing the total by 10, the answer would come out to 7.9. So these are the means of the two groups of people. A mean is just an average. So this is the average of the 10 working students, and this is the average of the 10 non-working students. This graph is a nice summary of my data set, and I can show this graph to other people to clearly communicate what my results are showing. If I showed this graph to another person, they would be able to clearly see that the 10 non-working students were getting more sleep than the 10 working students on average. Now that I've summarized my data set by creating this graph, I'm going to want to interpret my data set. I'm going to want to reach a conclusion about what this data set is showing. If I look at this bar graph and I reach the conclusion that working college students appear to be getting less sleep than non-working college students, then I've interpreted my data. I've reached a conclusion about what the data is showing. Now that we've covered collecting, describing, and interpreting data, let's discuss the difference between a data value and an observational unit. This is a little bit more vocabulary. A data value is a single piece of information that describes something about a person, animal, thing, or place. We've covered the definition of a data value already. An observational unit is a person, animal, thing, or place that is being observed or studied. In other words, an observational unit is a person, animal, thing, or place that a researcher is gathering information about. Here's some examples of observational units. If I record that a certain house is 200,000 square feet, then 200,000 square feet is the data value, and the house is the observational unit. So this is the data value, and this is the observational unit. If I record that a certain dog weighs 45 pounds, 45 pounds is the data value, and the dog is the observational unit. And if I record that a person is 61 inches tall, then 61 inches is the data value, and the person is the observational unit. When you're collecting data about a person, and that person is participating in a study, then you would usually call that person a participant instead of an observational unit. The reason why is because you want to acknowledge that that person is actively participating in a study. So a human observational unit is usually called a participant, even though person who is participating in a study technically is an observational unit. A researcher can obviously collect data from more than one observational unit. If I record the sizes of 10 houses, then those 10 houses are my observational units. If I record the heights of 10 trees, then those 10 trees are my observational units. So each observational unit provides one or more data values to the researcher. On this slide right here, the five houses are the observational units, and the price of each house is the data value. So if I've recorded the prices of these 5 houses, the 5 houses are the observational units because they're the 5 things that I've gathered information about, and the 5 prices that I've recorded are the 5 data values. They're the 5 pieces of information that I recorded about the houses. If I record the weights of 5 dogs, then the 5 dogs are the observational units. They're what I've gathered information about, and each of the weights that I've recorded is a data value, because each weight is a piece of information that describes a certain dog. If I record the heights of 5 people, each person is an observational unit, or a participant if they're actively participating in a study by taking a survey. And each height that I've recorded is a data value, because each height is a piece of information that describes something about a certain person. The researcher will typically collect more than one data value from each observational unit. For example, a person might record not only the price of each house, but also the size and location of each house. If we look back at this example right here, a person might record the price of each house, and that would be one column of data, but the person might also record the size of each house, and those numbers, sizes of the houses, would go in another column. And the person might also record the location of each house, and those locations would go in a third column. When a person collects more than one data value from each observational unit, the data set becomes a spreadsheet with rows and columns. Let's think about what the spreadsheet would look like in this example. If I was recording the price, size, and location of each house, then the price, size, and location of the first house would go in the first row. The price, size, and location of the second house would go in the second row, and the price, size, and location of the third house would go in the third row. So I would have 15 data values inside my spreadsheet, because I would have, this column would have the 5 prices, this column would have the 5 sizes, and this column would have the 5 locations. We'll talk more about the layout of the spreadsheet in a couple minutes. First, we have to talk about one more word, which is called a variable. A variable is something that varies between different people, animals, things, or points in time. Variable is just something that's not always the same. The word variable means able to vary. So anything that can vary is a variable. In algebra, the variable is the letter x. The reason why the letter x is called a variable is because x doesn't always come out to the same number. In one problem, x might come out to 12, but in another problem, x might come out to 25. A variable doesn't have to be a letter like x, y, or z. A variable can be something that varies in everyday life. For example, temperature is a variable because temperature outside is not always the same. On some days it might be 65 degrees, but on other days it might be 73 degrees. The weather is also a variable because the weather is not always the same. Since this is a social science statistics course, we'll be focusing on variables involved with people. For example, height is a variable because not everyone is the same height. Different people can have different heights. Gender is a variable because not everyone has the same gender. Income is a variable because not everyone has the same income. These 5 variables are just examples of things that can vary across different people. I mentioned how a data set is usually a spreadsheet. I wanted to discuss more about the organization of a spreadsheet. In a spreadsheet, each row contains data from one observational unit. So if I'm recording information about 5 houses, all of the information that I recorded about the first house would go in the first row, and all of the information that I recorded about the second house would go in the second row. Each column title is a variable. So if I was recording the price, size, and location of each house, those would be the 3 variables in my data set. Price would be a variable because the different houses would have different prices. Size would be a variable because the different houses might have different sizes. And location would be a variable because the different houses could be at different locations. And each of those 3 variables would be the title of a different column in my spreadsheet. In my spreadsheet, I would have a price column, a size column, and a location column. So those would be the 3 columns in my spreadsheet. Also, each cell or box in a spreadsheet contains 1 data value. Let's look at an example of a spreadsheet. In this spreadsheet, the 3 books are the observational units. They're the 3 things that I'm collecting data about. These 3 column titles are the 3 variables. If I'm recording the type of cover, the number of pages, and the weight of each book, those are the 3 variables. Because we can see that type of cover is something that varies because different books can have different types of covers. The number of pages is a variable because different books have different numbers of pages. And weight is a variable because different books can have different weights. So we can see that each row contains data from 1 observational unit, and each column title is a variable. One way to think about the difference between an observational unit and a variable is that the observational units are the people, animals, or things that you're gathering information about, and the variables are the ideas that you're studying. Let's look at another example. Well, first, we need to talk about how these 9 values in here are called the 9 data values. These 9 pieces of information are called the 9 data values because each of them is a piece of information that describes something about a book. So the 9 data values are 1, 2, 3, 4, 5, 6, 7, 8, 9. So in a spreadsheet, you can find the number of data values by multiplying the number of observational units by the number of variables. In this case, 3 units times 3 variables equals 9 data values. Now let's look at another example. Now we're recording the price, color, number of floors, and number of bedrooms of 3 houses. The 3 houses are the observational units. These are the 4 variables, and we have 12 data values inside the spreadsheet because 3 times 4 is 12. Here's one more example. We're recording information about 3 people, so the 3 people are the observational units, or we could call them participants since they're people. and they're probably participating in a study by taking a survey. These 4 titles are the 4 variables, and these 12 answers that we recorded are the 12 data values in the spreadsheet.